So we are going to continue from yesterday's lesson, or actually finish yesterday's lesson. We need to find a function value of cotangent 45. So I can say here is my 45, 45, 90 triangle. And if these two sides are 1 and 1, and this is square root 2, cotangent 45 is going to be 1 over 1, or just 1. Which would be the same as we talked about cofunction identities yesterday. So it would be the same as the tangent of 90 minus 45 degrees, which would also give us a value of 1. If I look at cosecant 60 degrees, cosecant 60 degrees is the same as secant 90 minus 60 degrees. Again, I can draw my special right triangle and say this is my 30-degree angle, 1, 2, and the square root of 3. So when we talk about cosecant of 60 degrees, we are talking about 1 over sine. So the sine of 60 degrees would be root 3 over 2. So the cosecant of 60 degrees is 2 divided by root 3, 2 divided by root 3, or 2 root 3 over 3. Speed is a distance measured over time. Similarly, angular speed is the amount of rotation over time. The angular speed is represented by the Greek letter omega. This is a lowercase omega right here, and it kind of looks like a W, but it's a little bit curved. So when I write it like that. That's lowercase omega. And lowercase omega is theta divided by the time. Theta is, of course, our angular rotation in radian measures, and the time is in seconds. The linear speed v of a point, a distance r from the center of a rotation, is given by v equals r times omega, where omega is the angular speed in radians per unit of time t. So we have an example where it says, while riding your bike, a piece of gum gets stuck to your front tire, which is 25 inches in diameter. What's the linear speed of the piece of gum if your tires are making 4 revolutions per second? So the first thing I'm going to do is I'm going to find the radius of the tire, because when I want to use the formula of linear speed equals radius times omega, I will need the radius. So my radius is going to be 12.5 inches. I also know that since I am going 4 rotations per second, the 4 rotations will be 4 times 2 pi, or 8 pi for the theta, over 1 second. So if I substitute this omega into my equation, I will get the linear speed, which is going to be equal to 12.5 inches times 8 pi over 1 second. So if I multiply these together, I will get 100 pi inches per second for the linear speed. And this concludes the lesson from yesterday. So we are going to now move on to the next lesson. In today's lesson, we are going to talk about finding function values. We are going to mostly use calculators, but you can also use the tables which are in the back of your book. The objective is that at the end of this lesson, you'll be able to find trigonometric ratios using a table and convert between degree and minute notation and decimal degree notation. We can measure angles in degrees and in radians. When we measure in degrees, sometimes the measure of an angle is a decimal. This can be converted into degrees and minutes. 1 degree is 60 minutes. And we are going to take the additional d out from here. So to convert degrees in decimal form to degrees and minutes, I'm just going to simply start out with the degree. It's still going to be 24 degrees. And if I use the decimal part, which is 0.25 over 1, will equal to 60 minutes and x. So I have to multiply the 0.25 and the 60 and end up getting 15. X equals 15 minutes. And we represent that by the little slash. So x will equal to 15 minutes. Therefore, 24.25 degrees can be converted into 24 degrees and 15 minutes. In the second example, we need to convert 57 degrees and 20 minutes into decimals. So again, I start out saying 57 point something degrees. So I am going to say x over 1 will equal to 20 over 60, or 20 minutes over 60 minutes. If I reduce this, I'm going to end up having x equals 1/3. So 1 divided by 3 is 0.33. So it will be 57.33 degrees. So let's go ahead and box this. And we can draw the conclusion that when we are converting from the decimal form of degrees to minutes, we are going to multiply by 60, but multiply only the part which is after the decimal point. And if we are going to convert minutes into the decimal form, divide the minutes by 60, and that will give you your decimal form. Your today's homework is going to be page 753, 28 to 37.